Okay, a simple way that they will ask will be like, for example, here. Okay, for part 1, it's actually very easy. You just need to do a sketch of EX. So just make sure your shape is correct. And then the intercept is correct. So there is a dotted line here. Okay, the second part, some people will find that that's a difficult one. So that is under what we call graphical solution. So the approach will be you always manipulate from the equation till you get the graph. So you will get to this format where this is your graph, and then you will need to add in a straight line. So later on, the idea is the solution actually comes from the intersection of the graph and straight line. So that is the idea of graphical solution. So in this case, I need to execute. So this is half x. You need to manipulate until your graph appears. So this is your graph. So you got to bear in mind, you need to make EX appear. So that is your exponential or logarithm technique. So you got to try to squeeze out an EX. So that is also your indices. So I change the square root to power half. I bring down the power. And I cancel the half on both sides. And not forgetting that this is log base E. And I'm going to change it. My graph appear. Can you see? This is my graph. So once my graph appear, that means, right, y is equal to 5 minus x. So I will need to add in this line. I need to add in this line, and I got to find how many solutions are there. So again, when you're going to add in a straight line, we know that it's a straight line and it is a negative gradient. So can you see that there is a negative gradient? You should be questioning, so what's the x-intercept, what's the y-intercept? You go and find the x-intercept, y-intercept, you should get something like 5 and 5. So this should be the straight line. And how many solutions are there? There's only one solution, because there's only one intersection. So in this kind of question, you will not be asked to find the value of the intersection. This is a sketch, it's not a graph. You can only find how many solutions, which can be seen by the number of intersections. So the typical structure of this type of question will be, they ask you for a sketch, and then the second part is the manipulation. So same thing on the next example, you are supposed to sketch a ln x, which I think is pretty easy, no trick at all. You just need to remember the shape. The shape and the intercept. Okay, so there's a dotted line somewhere here. Okay, it is the manipulation that sometimes some people find difficult. So the equation is here. Your job is to manipulate until you can see ln x. So inevitably, we will need to ln both sides. Then you got to bring down the power. And don't forget, this is a value of 1. After you bring down the power, you realize you're getting very close to the graph. ln x will be x minus 3 over 2. So can you see this is your graph? So the line to add will be this line. And if you look carefully, it is a positive gradient. So if that is a positive gradient, you actually need to make sure you calculate properly. So in this case, right, if you do the intercept, it will be a negative. It will be something like a negative. It will be something like this. It will cut at minus 1.5. And I think the y-intercept, the x-intercept, you can calculate. I think the y-intercept, you will get a 3. Okay, let me do the y-intercept, the x-intercept will be y equal to 0, half x minus 1.5 equal to 0. So you will get a 3. Okay, so in that case, I got to draw in a proper manner. So I got to make sure where somewhere 3 is here. So actually, if you look right, it seems like it doesn't cut the original graph, but it actually do cut. Because can you imagine if I extend this part? So how many solutions do you get here? You actually get 2 solutions. So there should be 2 solutions. So there are 2 intersections. So there should be 2 solutions. So generally it will go like this. So it will be the same thing like example 5. So example 5, if you look, it's a negative coefficient and the base is more than 1. So negative coefficient and the base is more than 1. So it should look like this. So it should be somewhere coming down. Check for the y-intercept. Putting x equal to 0, you get a 1. And there's a dotted line here. So again, the second part is the manipulation. So this is the equation, looks like quite a complex one. So this is the equation to solve. And you actually need to manipulate so that you can get a 4 minus x. So some amount of indices is involved. This is a 1 over. Square root is a power half. So I actually got a minus half power. And again, you bring down the power. And you divide by minus half on both sides. Okay, you can divide over. So once you divide over, you will get a minus x. That's where you do your basic in this logarithm. If you do your basic logarithm, this is what you gotten. And this is actually your graph. So this is the line that you're supposed to add in. So you add in with the idea of where is the x-intercept and where is the y-intercept. So do calculate out. So it's quite easy. You will find that both are 3. No, minus 3 and 3. And how many solutions are there? There's only one intersection. So there's only one solution. So generally, that's how you will be asked for your exponential graph or your log graph.